Welcome to EDU World Space.
So the maximum speed will occur when all of the potential energy of the two protons are converted into kinetic energy. So to put this into an expression, let's start by looking at the formula for kinetic energy, which is equal to 1/2 mv squared. And in this case, since there are two of these protons, we can just multiply it by 2. And in this case, the 2 and the half cancel each other out. So the total kinetic energy of both the protons is mv squared. Yep. So now if we just plug in the values for the mass and its velocity, we can find out. Now if we plug in the values for its mass and the kinetic energy, which we know is equal to the potential energy, since all of the energy is converted into kinetic energy, and theoretically none of it is lost. So here, if we isolate the variable v by moving the mass to the other side and the square root as well, you get that v is equal to the total kinetic energy, which is also equal to the potential energy, as we just discussed, over a square root, since we need to square the opposite side to isolate the variable v for velocity. So now if we just plug in the values, so 30 so actually we need to first calculate the kinetic energy, since we don't know what the total kinetic energy is at this point. So now we can just let this expression sit, since we know that we're going to have to come back to it after calculating kinetic energy. So if you were just to calculate the kinetic energy on this side over here, let me just make that a straight line. So the kinetic energy is equal to the potential energy, and we can calculate the potential energy by using Coulomb's law. So Coulomb's constant times the first charge and times the second charge, all over the radius, or the distance between the two nuclei. So in this case, we know all the constants, so we can just plug them right back into this equation. So the Coulomb's constant is 8.99 times, hold on, let me get that a little bit nicer, times 10 to the power of 9 times 1.6, so this charge is the first proton, 1.6 times 10 to the negative 19, and times another 10 times 1.6 times 10 to the negative 19, which is the same as the other proton. So we can actually just square this whole expression, since it's the same charge, over the radius, which is equal to 0.75 times 10 to the negative 9. Now, if you put this into our calculator, we're going to find out that the potential energy, the maximum total potential energy, is 30.6 times 10 to the negative 20 joules. So now if you plug this value, because we know that the maximum speed will occur when all of the potential energy is converted into kinetic energy. So this potential energy is equivalent to this kinetic energy in this expression. So if you use this values in this expression, we're gonna get the maximum velocity, since we already know the mass of these two protons. So it is 30.6 times 10 to the power of negative 20 over the mass, which is 1.66 times 10 to the negative 27 over, and this whole thing is going to be square rooted. So now we know that if you plug this into our calculator, we get that the maximum velocity is 1.36 times 10 to the fourth meters per second. So this velocity is reached at a long distance of separation. So that's the answer to the second part. Reached at reached So let's not write that out since it's too difficult for me to write words apparently. So I can just verbally answer the second part and saying that the velocity is reached at a long distance of separation. So now moving on to the final part to find the maximum acceleration. So when a force acts on a proton, it acquires maximum acceleration, which is found by this equation. So let's draw a little separation here. So we know we're moving on to the last part of the question. So the formula is A is equal to the maximum force over mass. So this is just straight out of Newton's second law, and we already know the values for both these. So the maximum force is calculated. Actually, we don't know the maximum force yet, since we need to calculate that using its maximum velocity, and the proton acquires its maximum acceleration when the force on it is maximum. So when the force is maximum and the two protons are at rest. So to find out the maximum force, we know that F is equal to KQ. Once again, this is Coulomb's law over the radius. We know that this is equal to 8.99 times 10 to the 9 times the two charges, which is 1.6 times 10 to the negative 19 over the radius, which is 0.75 times 10 to the negative 9 and squared. Sorry, there's a radius squared over here. So this is calculating Coulomb's force. So this whole thing squared. So if you put this into a calculator, we find out that the force is 40.9 times 10 to the negative 11 newtons. Let me just get rid of that negative sign and make it a little bit nicer. Newtons. So now if you plug this force into this equation for the maximum acceleration, we get that it is over 40.9 times 10 to the negative 11 over the mass, which is 1.66 times 10 to the negative 27, and and this is equal to plug it into a calculator, 24.6 times 10 to 16 meters per second cubed. Squared, sorry, for acceleration. So once again, these are our two answers to the acceleration. The maximum acceleration, it happens at the maximum force, which we calculated over here. And going back, we have the maximum velocity, which occurs at a long distance of separation. And that's it for this question.